A rational expression in general is when we have the quotient of two polynomials. So we have something, we have a polynomial on the top of a fraction and a polynomial on the bottom of a fraction. And they could be as simple as having an x or a number on the top or the bottom, or as complicated as having like x cubed plus a whole bunch of stuff on the top or the bottom. Okay. Simplest form of a rational expression is just like the simplest form of any other fraction when the numerator and the denominator have no more common divisors. So we can't divide either the top or the bottom by anything else to simplify them. Okay, we can't cancel anything out of either of them. That is simplest form. So the first thing we're going to do in section 8.4 is just look at writing rational expressions in simplest form. So first example, what is x squared plus 7x plus 10 divided by x squared minus 3x minus 10 in simplest form? And state any restrictions on the variable. So just like when we talked in the first sections of this chapter, the first thing that you want to do when you are dealing with a problem that is a rational expression, the first thing you're going to do is factor the numerator and factor the denominator. So factoring x squared plus 7x plus 10, we're looking for two numbers that multiply to 10 and add to 7. So numbers that multiply to 10 are 1 and 10, 2 and 5. 2 and 5 are the ones that are going to add to 7. Factoring x squared minus 3x minus 10, we're looking for two numbers that multiply to negative 10, so they're going to be opposites and add to negative 3. So we still have 1 and 10, 2 and 5, and one of them has to be negative. So these are the two. 2 and 5 are the ones that are going to have a difference of 3. But in order for it to be a negative 3, we want the 5 to be the negative one. So we would have x plus 2 and x minus 5. So our original expression could be written as x plus 2 over x plus 5, or times x plus 5, over x plus 2 times x minus 5. So we factor the top, factor the bottom, and then we look at if there is anything that can cancel. So the x plus 2's can cancel. So our simplified expression is x plus 5 over x minus 5. Now remember, the x plus 5 on the top is a family. We can't just cancel the x's or cancel the 5's. Okay, we got family on top, family on the bottom. Those have to stay as they are. Now, we get to the restrictions on the variables. So what we've been looking at in the first few sections is where we're going to have, vertical asymptotes. Where is the denominator going to equal 0 and cause problems? Be undefined. So once you have this factored, okay, if we look at our denominator, what values are going to make the denominator 0? What number could we put right here to make this part 0? Negative 2. Opposite of this number. So negative 2. And what number would we put here to make this 0? 5. So our restrictions are x cannot equal negative 2 and x cannot equal positive 5. So even though we canceled out the x plus 2's, we still include that in our restriction. Part A is different because there are no addition and subtraction signs. It is all stuff being multiplied over stuff being multiplied. This is a situation where we can cancel stuff all day long. Or you can just think of it as you got numbers. 24 divided by 6 is, that's a negative 6, so that would be negative 4. Then deal with the x's. So the two of these will cancel with two of these, leaving us with 1. And if we look at the y's, two of these y's will cancel with two of these, so we're left with a y on the bottom. That's it. But what are our restrictions? So we have x's on the bottom and we have y's on the bottom. We don't have any adds or subtracts. So x can't be 0 and y can't be 0. So our first step is to factor. So numbers that multiply to 8. 1 and 8, 2 and 4. The ones that are going to add up to negative 2 are 2 and 4. So what's the problem? The 8 is positive. But the 8 is positive. The honest answer to this issue is that I wrote it wrong. I'm sorry. This should be minus, this should be plus. Because, yeah, the way that I wrote it is actually not factorable. I apologize. So now they can be opposite signs. One can be negative, one can be positive. So since the 2 is positive, the larger number 4 should also be positive, and the 2 will be negative. Positive 4 plus negative 2 gives us positive 2. Positive 4 times negative 2 gives us negative 8. And in the denominator, we're looking for numbers that multiply to 6 that are going to have the same sign and add to negative 5. So be careful on the 5 and 6 one. Okay, well, anytime you have a quadratic that has a 5 in the middle and a 6 at the end, careful, pay attention to that sign in front of 6. If it's positive, you're going to use 2 and 3. If it's negative, you're probably going to use 1 and 6. So just be careful on this because, yeah, it's a tricky one. But since they are the same, since they have to be the same sign, negative 2 plus negative 3 is going to add to negative 5, and negative 2 times negative 3 is going to multiply to 6. So there's our factored form. So we have x plus 4 times x minus 2 over x minus 2 times x minus 3. We can cancel the x minus 2's. So our simplified form is x plus 4 over x minus 3. And x can't equal 2. And x can't equal. So it can't equal 2 because of this one. And it can't equal 3 because of this one. Yep, so part C. So 12 minus 4x. Is there anything that 12 and 4x have in common? How about they both have 4 in common? They're both divisible by 4, right? 12 divided by 4 is 4 divided by 4 is 1. Top. What's the bottom going to factor into? So we have an x and an x, two numbers that multiply to -9 and add to 0x, right? So the two numbers that multiply to -9 and add to 0 are 3 and -3. Okay. So our factored form is 4 times 3 minus x over x plus 3 times x minus 3. Now, why is there anything we can cancel right this second? No. Can we change this slightly so that it will cancel? So right now we have a 3 minus x and an x minus 3. They're opposites of each other. The signs are backwards. We can change that. So if we factor out a -1, okay? If we take out a negative, the 3 becomes negative. If we take a negative out of x, it becomes positive. So basically, you can always switch a binomial around as long as you just take out a negative. And then we'd be over x plus 3 times x minus 3. Now, we could cancel out the x minus 3s. So our simplified form would be 4 over x plus 3, and our restrictions would be x can't equal -3 and x can't equal +3 from the denominator right there.